Hello everyone, my name is Jasper Jiahui Xu. I'm a veterinarian and now a PhD candidate in Center for Animal Health and Food Safety at the University of Minnesota, United States. Today, my presentation topic is space-time dynamics and the risk factors for African swine fever in the Philippines. So first, I would like to special thanks to the Bureau of Animal Industry and the ITCPH, our important collaborators in the Philippines, for their support in collecting the data and the workshop organization to assist our research development. So today's outline will including the ASF in the Philippines, our research questions, and the impact and the conclusion of our research. We will elaborate that why the ASF is a One Health issue, not only in animal health, but also public health and environmental issues in our conclusion. So first of all, in the introduction, ASF is caused by African swine fever virus. It is a double-strand DNA virus with a complex structure. The genome look like in the right up figure. It is outer capsid P72 categorized into 24 non-genotypes. The current genotype mainly impact the Asia Pacific in the genotype 2 and encoding over than 150 proteins. All kinds of pigs, including the domestic pig and wild boar, are susceptible to the pathogenic effect of the virus. And one important thing is that the virus, does not pose a threat to human health. So it mainly impacts the swine industry. For the clinical sign, the ASF, clinical sign of ASF including the high fever, decreased appetite, diarrhea or vomiting, which is very similar to other common infectious disease. But we need to notice that abortion or the sudden death is also a clinical sign for ASF. And in the early phase of epidemic, the mortality could be very high, up to 100%. Here is a map and a table of the first year of ASF in Asia and Asia Pacific. The color including different kind of transboundary animal disease, including ASF and foot and mouth disease, according to the reference from Japanese government. So for Philippines, it is in the middle of Asia Pacific. It is archipelagic countries with more than 7,600 of islands in Southeast Asia. There is no foot and mouth disease outbreak because the disease eradicated in 20th century. The first ASF outbreak is in July 2019. And the weather and the temperature in the Philippines is typically maritime and tropical. There's a lot of rainfall and very humid. Here is an overview of animal impact in the Philippines. At the beginning of the impact is in 2019. The cumulative effect region in the first year of outbreak is 3. But at the end of 2023, 17 regions. It means 100% of the regions and 89% of our province has shown the cumulative effect regions. The map in the right is provided by the government Department of Agriculture in the Philippines. The map is announced in November 2024. So it is just a week ago of the data and showing some of the endemic municipality in many regions and many provinces or municipalities. The swine farming in the Philippines is typical look like the left. It is called the backyard or smallholder farms with the heads of pigs under than 20 heads of pigs, or they also keep other livestock such as chicken, cattle as well in this kind of farming setting. The other part of the farming is called the commercial farm. The backyard is approximately 70%, and the commercial fund is approximately 30% over the past 30 years. Although the backyard is slightly decreasing, but the ratio didn't change very much. It maintained the ratio. So our research for the Philippines, in the ASF in the Philippines is main 3 research questions. First, we want to make a descriptive spatial and temporal analysis. We want to identify where or when is the disease happening more frequently. Second, if we can identify specific pattern in the transmission of ASF in the Philippines. Third, if we identify the pattern, then what are the risk factors in the context of the Philippines? Then we want to identify the specific risk factor we can management or control. So we use the data set from the government with more than 19,000 of farm outbreak, beginning as the August 2019, the first outbreak, to July 2022, among 36 months of the data. So the raw data look like this. We have months, date, year, and different kind of administration level, and how many positive farms in that administration level. The outbreak location was approximated using the centroid of latitude and the longitude of the smallest administration level of the farm which are located. We go through different methodologies, include geostatistics and R programming. But basically, we are mainly evaluate the spatial epidemiology, the disease dynamic, and the risk factors in our methodologies. So our results showing that the disease, the cases is more clustered in central region, where the capital in the Philippines. And the epidemic curve in the right, we are showing the 3-year epidemic curve. The table showing different color of light orange and the dark orange. The light orange is the first half of the year between January to June. And second half of the year is the dark orange, is July to December. The epidemic curve shows the pattern of ASF recurrence, especially in the second half of the year. And we also identify the seasonal pattern with the highest frequency occur between August to October and the lowest between April to May, respectively. And we also do a permutation test called a space-time permutation. We want to identify if the outbreak in specific season and specific location at the same time. So we identify 5 clusters accordingly. We need the important in this cluster, we can highlight the cluster 1, 3, and 5. It all happen in the Luzon Islands, and when we look closer the timing, it is pretty similar timing. It all happened in the second half of the year. And if we see the radius of the cluster, the cluster 1 is 55 kilometers, but for cluster 5, it becomes 107 kilometers. That means the cluster showing similar timing, similar island, but the radius become larger, so the impact become more broadly in this region. We also use the data to simulate the bacillus reproductive number. The question behind that is we want to identify how contagious is an infectious is. In an individual level is how many secondary animal could one animal infect on average. But because our data is in a farm data, so given the data type, we want to answer the question, how many secondary farm, one infected farm could cause on an average. If the number is above 1, means the disease is spreading and leading to a potential outbreak. If it equals 1, means the disease is stable. If it below 1, means the disease will die out or be eradicated. So here is our result from the beginning to the 36 months of data. At the beginning, the number is 1.1 to 6.5, which is pretty high and showing an epidemic phase. But at the end of the 36 months, it's showing an endemic phase. We use different kinds of basic reproductive model, but the result is pretty similar trend of endemic after 36 months of infections in the Philippines. The next questions we want to identify is called the risk factor. We use a method called the conjoint analysis for the risk factors. We ask the experts about different risk factors of some hypothetic funds. This hypothetic fund including some literature risk factors. For example, we will ask the experts in the field with a hypothetic fund with different kinds of risk factor. Either they have using the swale feeding, no double fencing, no ticks, or yes ticks, or have other animal or livestock in this kind of simulated farm. And the expert in the field will answer the questionnaire. Do you think this kind of farm will have a ASF outbreak? They will respond yes or no. And they will rank different hypothetic farm by their empirical experience. So we will get different kinds of data, the rank data or the ASF binary yes or no data in our questionnaire design. Then we will go into a logistic regression model to showing how the impact of the human behavior compared to other environmental factor of the risk factor in the Philippines. So our model of logistic regression model showing the top 3 risk factor of first is swale feeding use in the Philippines or the contaminated feed. Second is the personnel movement without trusted biosecurity. And the third is the lack of disinfection protocols as the top 3 key risk factor for ASF introduction at the farm level. We also ask the behavior and the compliance in the Philippines. So the compliance rate of the policy by the government is between 50% to 80%. But importantly, most people agree that animal will be sold as soon as a disease is not noticed, up to 95% of the observation. When we are doing this kind of research, we observe that it is more than animal disease issues in the Philippines, because it is also a social economy issues, because the pork price has risen significantly year on year. And it is also a public health and mental health issue for the veterinarians and the farmers, because the total depopulation is the policy. So farmers experience important mental health issues in a public health concern. There is also environmental impact because people they were dumping the carcass of ASF infected pigs in the water source. They will have a pollution to the soil or water or the air in the environment. So our summary is we are showing the recurrence pattern of ASF in Luzon Islands with a high seasonal pattern between August to October. And human behavior is the main driver of ASF spreading, highlight the need for intervention on biosecurity and movement control. Evidence of ASF transition toward an endemic state in the Philippines. So we need to thinking about the long-term prepare for the disease. And therefore, public-private partnership will be very important for our future research. So the response, what we need for the future, we need to thinking not only in the animal health, but also the supporting for the farmers, communities, and address the food security, physical health, and mental health as well. We also want to try to mitigate the negative impact of the environment to protect the One Health as a whole picture. So the conclusion is considering the ASF response from a holistic point of view will be very important. Thank you for listening, and here is my acknowledgement to our collaborator and funding sources. And here is my email. If you feel questions and which is not unclear, please send me an email and I will try to answer as possible as I can. Thank you very much.